Welcome to this video on the merge sorted array problem. In this video, we will discuss how to solve this problem using different approaches. The problem is to merge two sorted arrays into one sorted array. The problem statement is as follows. Given two sorted arrays nums1 and nums2 with sizes m and n, merge nums2 into nums1 as one sorted array stored in nums1, which has length m plus n, for example. If nums1 is 1, 2, 3, 0, 0, 0, and nums2 is 2, 5, 6, the output should be 1, 2, 2, 3, 5, 6. One way to solve this problem is to use a brute force approach. We can iterate through both arrays and compare the elements. If an element from nums2 is smaller than the current element in nums1, we can insert it into nums1. However, this approach has a time complexity of O and 2 due to the insertion operation. A more efficient approach is to use two pointers. We can start from the end of both arrays and compare the elements. If an element from nums2 is larger than the current element in nums1, we can place it at the end of nums1. Otherwise, we can place the current element from nums1 at the end of nums1. Let's go through the step-by-step walkthrough of the optimized approach. We start by initializing the pointers I, j, and k. We then compare the elements at indices I and j, and place the larger element at index k. The time complexity of the optimized approach is O, n, and the space complexity is O, 1. This is because we only use a constant amount of space to store the pointers, and we only iterate through the arrays once. In conclusion, the merge sorted array problem can be solved using a brute force approach or an optimized approach using two pointers. The optimized approach has a time complexity of O(n) and a space complexity of O(1). If you want to learn more about array problems, check out our next video on the remove duplicates from sorted array problem.